Good morning. So today we're going to do a little, we're going to do an activity that has its origins in the history of statistics. It's one of the first experiments that used randomization and was designed by one of the famous statisticians, the pioneer in design of experiments, R.A. Fisher. And it's dubbed the Lady Tasting Tea Experiment. Here's a photograph of Sir Ronald Elmer Fisher. He was born in 1890 in London and died in 1962 in Adelaide, Australia. He got his position as a statistician, where he did a lot of his work in design of experiments and analysis of variance, at the Rothamsted Agricultural Experiment Station, which is in the UK. So in 1919, he started working there. And that Agricultural Research Institute looked into studying the effects of nutrition and soil types on plant fertility. And so a lot of scientists worked here, including R.A. Fisher, who was a statistician. So one of the things he is most famous for is introducing the concept of randomization, and we'll take a look at that in today's lecture. And the experiment that we're going to try to reproduce here is this Lady Tasting Tea experiment. And Basu, who's an eminent statistician, said that this experiment, the famous case of the Lady Tasting Tea, was one of the two supporting pillars of the randomization analysis of experimental data. Fisher used this experiment when he was teaching students about his field of design of experiments. All right, so this is actually a true story. So this experiment grew out of an impromptu situation at the Rothamsted field station. They had a regular tea every afternoon, and one afternoon he was pouring a cup of tea for a lady who was waiting for some tea, and that's Dr. Muriel Bristol. And he offered her a cup of tea, and she politely declined and said, no, thank you. I actually prefer my tea with the milk poured in first before the tea. And supposedly Fisher said, nonsense. I can't believe you could tell the difference. And she said, I'm sure I can tell the difference. And someone else at tea said, let's test her. And so that was William Roach, who was soon to become engaged to Dr. Bristol. It says Miss, but she also had a PhD. And essentially, on the spot, Fisher designed an experiment to test whether or not she could really tell the difference between a cup of tea that was prepared with the milk poured in first and then the tea, or the tea poured in first and then the milk. Supposedly, the actual results of the study or of this particular experiment are not published. He does describe in one of his books how he actually designed the experiment, but he doesn't give the actual results. But supposedly they were convincing enough that, in fact, he did believe after the experiment that she could tell the difference. So what I'd like to do today is, is to actually go through the process of what some of the questions that Fisher must have considered when he was trying to design this experiment. So one first question that comes to mind is it enough to just give her 2 cups of tea, one with the milk poured in first and one with the milk poured in after the tea? Would that be enough to convince you that she could really tell the difference? So I'll post that to the class. No? Why not? She has a 50-50 shot of getting it right, and so if she gets it right, you could say, well, that could easily have just happened by luck, by chance, right? So another question is, how many cups of tea would she need to actually taste before she convinced you that, in fact, she could get it right? So that was one of the things that Fisher considered. Another was, should you present her with pairs of cups? So suppose you decided, oh, we need more cups of tea for her to taste and for us to be convinced. But there's still the issue of, how do I present the tea to her? Is it, here are 2 cups, one's with the milk first, one's with the tea first? Taste them and tell the difference? You don't think so? Why not? You want it to be blind so she has no idea. Well, she still wouldn't know which was which. So it's a legitimate design. There are several legitimate designs. So she would know each time that one would be with tea first and the other would be with milk first. And so each time she did it, she'd have a 50-50 chance of getting it right. But if she did it many times over, each time getting it right, at some point you hopefully would be convinced that it wasn't just guesswork every single time. There are other things, such as how warm or cold the tea is, how sweet it is. If there were any differences in, for example, what if Fisher was working with Roche, and what if Roche made all the ones with the tea first, and Fisher made all the ones with the milk first? Do you see any potential problems with that? What do you think? I saw you nod. He could put in a different amount of milk, for example, and so she could simply tell the difference by how much milk was in it and not really which one came first or last, in which case then it also reduces to 50-50 that she gets it right, if she can really therefore tell the difference. So you want them to be you want the cups of tea to be prepared in ways that are as similar as possible. The exact same amount of sugar, the exact same amount of milk, the exact same temperature of tea, and the exact same temperature of milk. Likewise, we see this really very pretty teacup. We'd like the teacups to look the same as well. And then maybe you'd be convinced, if she got it all right, if you gave her many cups, that she really could tell the difference. So I did this experiment in a class last spring with, instead of tea with the milk first or not, it was with Coke and Diet Coke. And I had a student in the class was volunteered to be the expert and did very well. And then afterwards, another student said, that's so easy between Coke and Diet Coke. What you'd really like to do is test something like Mexican Coke and Coke. So, can you tell the difference between Mexican Coke and Coke? So here's a bottle of Mexican Coke. You can tell that it's Mexican Coke for a couple reasons by looking at it. How can you tell that it's a bottle of Mexican Coke, yeah? It's in a glass bottle, that's right. What else?
It's written in Spanish.
You see that refresco and no retornable are Spanish words, which would be a clue that it's Mexican Coke. What's the difference between Mexican Coke and Coke? Yeah? Mexican Coke sweetens their Coke with sugar, whereas what about Coca-Cola made in the U.S.? What's that? Yes? Corn syrup. Can you read? I took a little picture on my cell phone, and You can see the ingredients on this bottle of Coke: carbonated water, sugar, caramel color, phosphoric acid, natural flavors, and caffeine. That's the Mexican Coke. And here's again, as you said, pointed out, I cannot actually get Coke made in the U.S. in a bottle. This is a can of Coke. Carbonated water, high fructose corn syrup, caramel color, phosphoric acid, natural flavors, and caffeine. So that's the difference. The big difference is that you can taste the sweetness is from corn syrup or from sugar. Is there anybody in the class who thinks they can tell the difference between those two? You do? Would you like to volunteer? Yeah, right now we're going to do this. So you can stay there for a second. We're going to talk about it first. So let's try it. So what I thought we would do is I would tell you exactly how R.A. Fisher did it, and we would reproduce R.A. Fisher's experiment. So I'm going to swap over to the document camera. Good thing I took the bottled Coke out first. Thank you, Mike. All right, here they are. So the Coke, the Mexican Coke, and the can of Coke. Thank you for picking up my mess. And they have been kept in the same refrigerator and then moved from the refrigerator to this little cold pack, so they should be the exact same temperature. What Fisher did was he made 8 cups of tea, 4 of each kind. So we will provide, your name? Jeff, with 8 cups of soda, 4 of each kind. And the lady was told there were 8 cups, 4 of each kind, and then was asked which 4 had the milk added first. So we're going to ask Jeff the exact same thing. And I thought it would be easier to use these poker chips, where a red poker chip is for the U.S.-made Coke and a blue is for the Mexican Coke. And so we'll give him 4 poker chips that are blue and 4 poker chips that are red, and he's going to use them to mark each cup. All right. So how do I go about pouring the Coke into these cups? We have a question? Yes?
Yeah, does he choose before, like after he drinks each one, does he make a choice, or can he compare them with the others?
He can compare them with the others. Very good question. Does he have to? In fact, I brought the mic today so that you can have your questions get recorded. But the question was, does he have to choose as he's drinking each one, make the decision, or can he choose at any time? He may choose at any time. What other questions or ideas do we have? Do you have any advice for Jeff? Don't what? Yes, advice for Jeff? You said something? Oh, the mic makes you shy?
He should cleanse his palate in between.
Yeah, so
preferably with some of
that's
that.
why I brought this water along. He should.
I don't think the mic is working.
You don't think it's working? Yeah, the battery might be. Hello? Dang. Yeah, I think the battery might be dead. It says it's working, but hello? Hello? Dang. All right, so I guess I will repeat your questions. He said cleanse your palate with the water. Any other words of advice? That's it? Yes? You should do it pretty quickly so it doesn't go flat. Well, it would still taste, you supposedly could still taste the difference maybe. Yeah? Yes?
I would say take small sips, because normally if you take a big gulp, it's hard to taste.
Take small sips. Yeah, that's, you sort of see that with those professional tasters, right? They sort of swirl it around and take little sips. But there's another thing. I did this once more than a year ago, and this student just downed the whole cup. And after a while got overwhelmed having had so much soda, even though they were little tiny cups, and couldn't go, and got confused, and couldn't go back. And so if you take little sips, then you still have the opportunity to revisit a cup. Ellie?
Take breaks between sips?
Take-
Or between cups?
Take a little bit of a break so that what? The flavor kind of dissipates?
And so you remember each one.
And you can remember what that particular flavor was or that taste? Yes?
Suggest instead of cleansing your palate afterwards, take one sip and take another sip immediately after.
Do you got the contrast? So you suggest take one sip, then the next one, and see that they're the same or different? So rather than cleanse your palate, try to get a contrast right away? All right, we got lots of advice. I'd like a helper, 2 helpers, one to pour Coke and one to pour the Mexican Coke. Can I get some volunteers? Yes? Yes? Great. And we're going to make Jeff step out of the room. But one other thing. I've got 8 of these cups here. How am I going to present them to him? This is where Fisher used a randomization technique. So he randomized the order and said, yeah, there are 8 cups here, but you can't see them there. Too bad. You will once they've got Coke in them. Now I've got 8 cups and they're in random order. How do I figure out how to randomize the order? You were going to say something?
So you can put a number for each cup, and then put like a number to randomize it, and then like a number on the paper of
Very, yep, yep. I did that earlier today. So I have this random order, which I'm not going to show you because Jeff's still in the room. I used R. R has a random number generator. I used R to take the labels, M for Mexican Coke and C for regular Coke, and mix them up and give me a random order. And so that's the order we're going to use to put the Coke in the cups. All right, so can we have you exit the room, please? And my 2 volunteers, can you come forward? All right, so we need to remember if he messes up where the order of these things are. Here's a bottle opener. We need to remember which cup is which. So let's, as was suggested already, let's put a little marker on the bottom of each cup. How about an M and a C? Why don't you start doing that? Why don't you open up the soda? Be careful, might be jostled. Yeah, can you, yeah, where'd you put the mark? Can we see that? Okay. I don't think he'll be able to, you could just put an M on half the cups. You think he can see it through the bottom? Are you worried about that? It's a good point. You can't, well, I guess if you knew it was there, why don't you put a little dot instead? I'll get you another cup. Just dot the ones that are Mexican. And what are your names? Stephen, can you start pouring into 4 blank cups the regular Coke? What else should Stephen make sure he does? Same amount in each cup, please, Stephen. And you are?
Oh, I'm Pierce.
Pierce is putting the dots. So which one's got the M on it? Here, I'll take that one away. All right, now there's a tiny dot. Oh, there's 2 M's. All right, that's all right. Oh. Okay. Any other advice for Pierce and Stephen as they're doing this?
So they're randomized in pairs, right?
No, they're not randomized in pairs.
All eight.
They are like this, and I will not tell you what order they are in so that you also will be amazed. Okay, next one. Start pouring. Same level as that one. No, just they don't have to be perfect.
Did you already pour that or this?
He poured that one. So. All right. This is regular Coke. Okay.
I just want to keep that. Oh, maybe a little more. Oops.
You guys are kind of chintzy with a Coke. Give him a little more. Talk about sips. Yeah, that's better. So these are the four Mexican, right?
Right.
Okay, that's good. All right, a little in that one. All right, so I'm going to do,
These two need more?
if you want. Thank you. You may have a seat. All right, can someone call Jeff in? In case you want a sip of water. There you go. All right. Thank you for being such a good sport.
So you said red was for American, blue for Mexican?
Yes, red's for American. And you know what? We're going to give you the mic.
What?
There you go. You have to tell us what you're doing as you're doing it.
Okay. Do I get the chips to help me arrange them?
Oh, did we
Or
give
sort
you
them?
those already?
Yeah.
Sorry. Here they are,
Okay.
the chips.
Red for American. Okay.
So put the chip down on the front of the cup or whatever.
Okay. Okay, so what I'm going to do is at first just guess, because it's the first one, I have no basis really. So I think this one's Mexican.
That's good. So you're just going to split them from one side to the other?
Yeah.
Good. Okay.
I think this one's American. I'm using the contrast idea that someone gave me. I'm arbitrarily just going to take a palette cleansing between pairs. I feel kind of like Hermione in the first Harry Potter book.
What's that?
I feel kind of like Hermione in the first Harry Potter book.
Would anybody like to try it while we're waiting?
I'm not sure about this one.
That's all right. You just brushed your teeth. How about you, Jeff? Did you just brush your teeth?
Not as recently.
And your left, which is it? Wrong.
Ouch.
All right. You want to try it too? I A couple more. Yep. So I'm going to hide which one's which, swap them around a little bit.
Oh, okay. So I'm kind of putting these according to a degree of certainty as to which I have. Like, if it's closer to the middle, then I'm not really as sure. And then what I do is, if I'm not sure, I retaste them so I can reorient myself, I guess.
Wow, it's very elaborate.
What I'm doing in my head is also trying to attribute a certain kind of sweetness. Like, this tastes more corny, kind of like, I don't know, it's hard to say. Like, the confidence for this comes from drinking this like thing called Jones soda, which is like touting itself as organic and with cane sugar and all that. And I thought it tasted different than like regular American sodas. But now I'm not so sure. I don't even like Coke much, so it just tastes sweet to me. Oh.
So far, 2 people have tried it, and I've gotten it wrong with a 50-50 chance. So why don't you stand over there so you don't see where I'm... Okay. Do you have a decision? You got it right. All right. Do you think Coca-Cola did conduct an experiment before deciding to go to concert? Probably, right? Do you have a decision already? Yeah, sure. But you gotta keep them in the same order, because I don't know, unless if you mix them up, then I won't know. Jeff, we're gonna call time on you pretty soon. Wrong. So let's just, we had 4 trials, yes? Yeah, come on down. We had 4 trials and we're only one of the 4 got it right. So can you tell the difference? Yeah, you can put it in upsize or voice. All right, and you're David. David wants to try it too.
Turn around.
Yeah, could you face the wall while I'm pouring? Okay, left hand, left hand. Jeff, you almost done there?
Okay, I'm done.
Are you done? All right, so we've got a divide here. On the left is just to make sure, the left is the U.S.?
Mm-hmm.
Okay, thank you. Let's see if Jeff can tell the difference.
You can tell the difference and not necessarily know which was which.
That's true. But let's talk about that question. Jeff could possibly tell the difference and not know which is which. What do you still think? I still think that's pretty good. That means he can tell the difference, right? Maybe those people who got it all wrong could also tell the difference. They just didn't know which one was Mexican, which one was American. All right, over here should be Mexican. And so I'm going to turn the cups over and see. He's already got one wrong. Oh, that one's right. Do you see that little dot there? No? Oh, well, there's no dot on that one, so he's... Yeah, there is. You guys can't see it, though. Right there is a dot, which this is not a very good... You can't see it. So I can enlarge the dot, but there's a dot on this one, which we wanted a dot on every one. Right there. Can you see that? Okay, there's a dot. So far, he's got only one... Oh, Jeff. Nothing. Okay, so now let's look at the American. So you know that one's right, but you know what about the others? Right, okay, there's a dot there. Okay, and you know what? Yes, you all are saying that there's two more. There's a dot there. And there's a dot there. Sorry, Jeff. You can't tell the difference. Well, what do you think? Can he tell the difference? Good question. So this gets related to what if he got them completely swapped? He didn't get them completely swapped, did he? But he only got one off, right? He got two wrong, but can you get one wrong in this situation? No, why not? You said no.
I mean, if you get one wrong, then you put the other one there, so it's like two.
Right, so you can't get, your score is either all right or all wrong, or two right and six wrong, or four right and four wrong. So there's no odd thing. So I want to switch back so we can actually do some calculations. Okay, so now that we have tried this, you've already discovered that there's only one way to get it all right and one way to get it all wrong. And he didn't do either of those. Would that have convinced you? Could he have just been guessing and got them all right? Yeah, what do you think the chance of that is? You think it's 1 in 16? I think it's a lot harder than that. How many ways to get one wrong? You have already told me. There are no ways to get one wrong. If you mistake one Coke as a Mexican Coke, then one of the other ones, the one that's a Mexican Coke must be in the Coke pile, and so you've got two wrong. So you cannot get one wrong, three wrong, or five wrong. You can only get two wrong, or four wrong, or six wrong. So what are the different ways to get two wrong? Well, you could have the first, if we had them in order, suppose I put them in order, Coke, 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 Mexican, 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 and then the first and the fifth were swapped. That's one way to get it wrong. Or the first and the sixth were swapped. That's another way to get it wrong. Or the first and the seventh were swapped, or the first and the eighth were swapped. So those are four ways to get it wrong. But then there's another four ways. The second and the fifth could be swapped. The second and the sixth could be swapped. The second and the seventh, the second and the eighth, another four ways. And then there's another four ways with the third and the fifth, the third and the sixth, the third and the seventh, and the third and the eighth, and another four ways with a fourth swapping with each of the Mexican Cokes. So there's 16 ways to get two wrong. How many ways are there to get six wrong? Same thing, 16. There's 16 ways to get 6 wrong, because that's sort of like exactly swapping the M's and the C's. So we can start counting up. There's 1 way to get it entirely right. There are no ways to get 1 wrong, 16 ways to get 2 wrong, no ways to get 3 wrong. How many ways to get 4? 0 ways to get 5. We just said there's 16 ways to get 6, no ways to get 7 wrong, and 1 way to get all 8 wrong. And so I can then fill that in with 36 ways to get 4 wrong. So altogether, there are 70 different ways of mixing this thing up. So to get it perfect, and you're just guessing, has a chance of 1 in 70, or about 14 in 1,000. And so to get them entirely right or entirely wrong, either one of those has a chance of 2 in 70, or about 28 in 1,000. And that's pretty good. Now, Jeff got 2 wrong. What's the chance you get 2 wrong? 2 or fewer wrong. That's 17 out of 70 to get 2 or fewer wrong. 17 out of 70 is nearly 25%. So do you think he's pretty good at it if he got 2 wrong? I don't think so. That could have happened 1 chance in 4. Right? So, sorry, Jeff, we're not going to call you an expert. And the rest of you guys, you got it wrong with your 1 guess. Right. So what was it that made this experiment so famous? Was that Fisher was able to use randomization. We randomized the order of those cups. And therefore, we could make these computations. We could say, if somebody's guessing, what's the chance they got them all right? Now, if there were ways to distinguish between the regular Coke and the Mexican Coke, aside from, well, related to its temperature or the color cup it was in or how much we poured in it or any of those things, then all of that sort of chance goes out the window. But if our cups are prepared as identically as possible, and the only thing different is the treatment, which is, did I pour American Coke or Mexican Coke in it? And then I mix them all up. Then I can answer questions of, well, what's the chance someone just guessing who can't really tell the difference at all, what's the chance they would get it right? So to be able to do these computations is based on the randomization property that Fisher introduced. And on Wednesday, we're going to go into another historical study, which we'll not do right now. But I want to first, I've got 1 correction I'm going to talk to you about, and then we're going to end the class today. Oops, sorry. So Fisher's design of experiments has dramatically changed the field of science and the field of statistics. And in 1938, he talked about, so the design of experiments means you're in there before you've ever collected the data. You're designing how you should go about collecting the data. And that's a very important piece. Many folks think of a statistician as coming in after the data have collected and taking averages and SDs, when it's also crucial for a statistician to be involved in the first steps before you collect the data. And so a very famous quote of Fisher's is, to call in the statistician after the experiment is done may be no more than asking him to perform a post-mortem examination. He may be able to say what the experiment died of. In other words, he may be able to tell you what you did wrong, such that the data that you've got back are useless for you to try and answer the question that's most important to you, that are the reason why you've conducted your experiment to begin with. So over the next week and a half, we're going to be looking at various designs for experiments and talking about how important it is in terms of being able to make sense out of the data that come back as to how you design it up front. All right, so that's the end of today's lecture. And I want to make one announcement is I want to make a correction to what I said on Friday about correlation coefficient. I've corrected the notes that were put up on BSpace, but it's still in the lecture. When we talked about the correlation coefficient and said how any kind of linear transformation will not change the correlation coefficient, there are two notable exceptions. One is that if you multiply all the data by 0, then your SD, your spread, is 0. And so you can no longer compute the correlation coefficient. Because the correlation coefficient, you need to put your data into standard units. You need to divide by the SD. If the SD is 0, that's a problem. So if that, A plus B times X, if that B is 0, that's a problem. The other is if B is negative. So what happens if B is negative? Then that's going to flip the relationship. So remember, a correlation coefficient says if above average values of X are associated with above average values of Y in general, you get a positive correlation coefficient. Well, if you multiply all those numbers by a negative value, then that changes the sign of the correlation coefficient. It does not change its magnitude, but it does change the sign. All right, so I'm going to end here. If anyone has any questions on their homework assignment, which is due on Wednesday at midnight, come on forward and I can possibly help answer them.